and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the topic of direct variation. Let's start out with a few definitions. When two quantities are related in such a way that the ratio of their values always remains the same or constant, the two variables are said to vary directly. Direct variations can be modeled by the equation y is equal to kx, where k cannot equal 0. The constant k in y equals kx is called the constant of variation. The value of k can be found by finding the ratio of y to x. Let's look at an example. The table below shows the relationship between the depth of a scuba diver and the time since diving below the surface. Determine whether this relationship represents a direct variation. If so, write an equation that describes this relationship. So what we're going to do is we're going to find or determine if there's a constant ratio of y to x. In other words, take each ordered pair and find their ratio. So negative 30 over 1, negative 60 over 2, and negative 120 over 4. Now, let's just put each one of these in the calculator. So I have my Desmos up in here, so I can find each ratio. Negative 30 divided by 1 is negative 30. Negative 60 divided by 2, negative 30, and negative 120 divided by 4, negative 30. So if every ratio of y to x is the same, this relationship is said to be a direct variation. There's a direct variation relationship between x and y. Now, the constant of variation is whatever that constant ratio is. In this case, it's negative 30. Now, the formula we use for all direct variation is y equals kx. So if we want to write an equation for this, we'll just use y equals negative 30x. Now, in our last question, it says use your equation to find the value of y when x is 10. So we're using our equation, so let's write it down. Y equals negative 30x. And then it told me the value of x was 10. So I'm going to replace the x with a parenthesis, and I'll substitute in the value of x, which is 10. And when you multiply that out, you get the value of y to be negative 300. All right, look at example 2. The table below shows the relationship between the total cost at a yoga studio and the number of classes you take per month. Determine whether this relationship is a direct variation. So remember, we're going to find the ratio of y to x. So in other words, our first ordered pair would be 93.75 divided by 5, and then 112.50 divided by 10, and 131.25 divided by 15. We want to find the ratio of each one of those. So let's start with the first one. 93.75 divided by 5 is 1875. Then 112.50 divided by 10. Now, you can see that those ratios were not the same. So we can stop. In other words, this one was 18.75 and this one was 11.25. Once you get two that are the same, you can stop and say, no, there is no constant of variation, so not applicable, and we're not going to have to write the equation because we're only writing the equation if it's a direct variation. All right, look at example 2. Each of the following represents a direct variation. Find the missing value the constant of variation, and an equation for y in terms of x. So if this is a constant of variation, to find our constant of variation, we just take y and divide it by x. So 9 divided by 3 is 3. So our constant of variation is 3. So our equation is y equals 3x. So if I want to find my missing value, 5 is my x value. I could just substitute in a 5 here, and 3 times 5 would give me 15. So our missing value is 15. All right. In our next problem, we have ordered pair 20, 10, 50, something. So to find your constant of variation, take the y value, 10, and divide it by the x value, 20. So 10 divided by 20 is 0.5. So our constant of variation is 0.5, which means our equation is y equals 0.5x. Now to find our missing value, we know that x is 50, so what is the value of y? Well, let me put our equation. I'm going to plug in our x value, which is 50. So I'll come over here and say 0.5 times 50. So that would give me a missing value of 25. All right, next problem. I want you to pause the video and try it on your own. All right, welcome back. In this problem, you should have taken your y value, 18, and divided it by your x value to get a constant of variation to be -6. Your equation would then be y equals -6x, and your missing value would have been -24. Check your answer with mine and correct anything that you might have gotten wrong. Look at problem 4. The value of y is directly proportional to the value of x. When y equals 75, x is 1/2. Find the value of y when x is 2 1/4. Now, we can solve direct variation problems by using a proportion. So in this problem, it told us that our numbers are directly proportional. That's the same thing as a direct variation. Two different terms for the same thing. And when two numbers are directly proportional to each other, we can use a proportion to solve them, where we compare the values of y and x. Now, in our first statement, let me highlight it here. Let me put it in pink. In our first statement, it says when y is 75, x is 1/2. So I'm going to write my first fraction as y over x. Now, I will put 1/2 as 0.5 just because it's easier to put in my calculator. Okay. Then I'm going to write a second fraction with my next sentence. Let me change to a different color. Find the value of y when x equals 2 1/4. So in this problem, we don't know the value of y, so I'll just put a y right there. But I do know the x value is 2 1/4. Now, if I write that as a decimal, it would be 2.25. All right. Now, after I get my proportion set up, I can cross multiply. So 0.5 times y is 0.5y. And then I'm going to multiply 75 times 2.25. And that's 168.75. Now, to find the value of y, I'll just divide both sides by 0.5. So 0.5y divided by 0.5 is simply y. And then I'll come over here with my calculator, 168.75 divided by 0.5. And that's going to give me 337.5. You may also see the answer written like this. So let me show you. These are the same thing, 337.5. All right. All right, look at example 5. The cost for electricity varies directly with the amount of kilowatt hours of electricity being used. So I'm going to stop right there, and because this varies directly, I can make a proportion. But what are we comparing here? Because they're not giving us X and Y anymore. But they're comparing the cost to the number of hours. So when we set up our proportion, we want to make sure the cost is on top and the number of hours is on the bottom. Okay? So in our second sentence, it says the cost for using 1,079 hours is $129.48. So the 129.48 must go on top because it's a cost, and the 1,079 must go on the bottom because it's number of hours. Now let me grab a different color highlighter here. How about blue? What was the cost for using 999 kilowatt hours? So in our proportion, we do not know the cost, but we do know the number of hours was 999. All right, once you have your proportion set up, now we can cross multiply. So 1079 times C is 1079C. And then here we'll multiply 999 times 129.48. So 129,350.52. All right, now to solve this, we're going to divide both sides by 1079. All right, so 129,350.52 divided by 1079. So that gives us a cost of $119.88. All right, example 6. In an electrical circuit, the voltage across a resistor is directly proportional to the current running through the resistor. So let me get a highlighter here. The voltage is directly proportional to the current. So if a current, so let me just set that up. The voltage is directly proportional to the current. All right. So in our next sentence, it says if a current of 12 amps produces 480 volts. So remember, the volts need to go on top. The current goes on the bottom. Okay. And then let's get another highlighter here. It says how many volts would a current of 3.5 amps produce? How many volts would a current of 3.5 amps produce? So we do not know the number of volts, but we do know the current is 3.5 amps. So now that I have my proportion set up, I can cross multiply. This would be 12V equals, and multiply 480 times 3.5, which gives me 1680. Then I'll divide both sides by 12. So 1680 divided by 12, which gives me 140. And what was the volts measured in? That would be volts. All right, example 7. The number of gift baskets Nikki can make varies directly with the amount of time she spends making the baskets. If she can make 4 baskets in 1/2 hour, how many can she make in 5 hours? Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. All right, this told me the number of gift baskets she can make, so baskets, varies directly with the time. Then I knew that she could make 4 baskets in 1/2 hour, so I said 4 over 0.5. And I wanted to know how many baskets she could make in 5 hours. So I cross multiplied 0.5b equals 4 times 5, which is 20. Then I divided both sides by 0.5, and I got that she could make 40 baskets in 5 hours. And that concludes today's lesson on direct variation.